Right, so what is that? Number one, sulfur dioxide, calculate the molecular mass, right? So same way, count the atom, plug in the value. Caffeine, we already did that actually. Okay. Unit will be AMU. The next slide is actually giving you the solution. All right. What is the molar mass of glucose? C6H12O6. So we will be careful what type of mass it is asking, molar or molecular, because depending on the type, our unit is different. So it is molar mass. So the unit will be grams, okay, or gram per mole, gram or gram per mole, not AMU, okay. Same way. Any question? Okay, no question. Now the next part of this chapter is really interesting, and it is a mixed calculation. It's not like, okay, so what we learned so far is just straightforward calculation, right? Calculate the molar mass, calculate the molecular mass, things like that. Now from these topics and on, we will do mixed type of calculation. Mixed means, by that I mean we can convert one things to another. Like gram of substance, we can convert to number of molecules, or the other way around. So I say it's a mole map conversion. Okay, this is just the title I like. It is not really a strict chemistry title. It's just I like that. Mole map conversion. That means we convert using the mole concept from one things to another. Think like this. If you have a beaker, you know beaker? Probably saw beaker in chemistry lab. So beaker is like this. Basically, it's nothing but a mug, like some mug, right? Mug. But in lab, we say it's a beaker, and that's graduated with some volume, maybe 200 ml, 500 ml. They come with different size. So imagine if you have one of that beaker with water, 10 gram of water, right? So water is a liquid, and normally we measure liquid in volume, right? Mil, but we can measure in mass also, okay? Using the density calculation. And water, you have 10 gram. So can you convert that, or can you calculate how many molecules are in it? You just see water in your beaker, right? And we can see molecule that's so tiny. Molecule is so tiny. Atom is also tiny, and molecule is also tiny. That's human eye cannot see molecule, but human can calculate the number of molecules because human are smart. Because of a lot of different scientists, we have formula how to calculate number of molecules from a given mass of water. So that's molecules, from mass to molecules. So what we do here, we need to use that mole map conversion. That means we have a given mass, 10 gram of water. We need to convert that into what? Molar mass. Okay? So our given mass convert to molar mass then convert to number of molecules. And this is really, really very important concept in chemistry. To be able to convert into grams to moles to number or the other way, it is really, really very good skill and very important. So this is the map or diagram, whatever you call it. This is the snapshot I got from a book, right? So what is this? Just try to understand inside. So gram of substance and this arrow going to left to right here. That means you can convert gram of substance to mole of substance by dividing molar mass, by dividing it with molar mass. So you see this value here. So it is telling us if you have some gram of any substance, you want to find moles of that substance, just divide it by the molar mass of that substance. And we know how to find the molar mass already, right? And then you want to find further number of molecules or atoms from the substance. You just multiply with Avogadro number. That's 6.23, 6.022 10 to the power 23. That's Avogadro number. Okay. Now the other way around. You want to find a mole of substance for number of molecules. From number of molecules, just divide it by Avogadro number. So this is multiplication in one direction. This is division in another direction. The opposite. Multiplication, division. Okay. So I want you to write this diagram 5 or 6 times. Just write it with using paper and pen. And then after that, you will understand the relation. And we will use the relation tomorrow to solve some of the mixed type of answer. Okay, and if you are curious, feel free to solve few of the next future slide using this map. And you don't need to remember actually this map. You can have it as a note during exam, but you need to understand how that is used and why this is this way. Helium is a gas. It has wide use, valuable gas used in industry and low temperature research, deep sea diving tanks and balloons. Okay, so it's very widely used. Now the question, how many moles of mole is used in chemistry for different chemical in different context. So we need to know the mole relation. How many moles of helium atoms are in 6.46 gram of helium? Okay, let's say someone using 6.46 gram of helium for their research. Now, if you want to know in terms of mole, how many moles are there? How many moles of helium are there? So for that, we need to know the molar mass of helium. Molar mass of helium, because molar mass means mass of 1 mole of helium. Okay, so we have here mass given. Now if we can convert mole to molar mass, I mean, that relation we can take, and then we divide the given amount of helium by the molar mass. That will give us mole. So molar mass of helium is how much? 2, right? Around 2. You need to see the periodic table.
4? Is it 4?
4, right? Yeah.
Yes.
So 4 gram per mole. Okay. So now you just can the mole of helium equal to 6.46 gram, right? Times, or what? Times, no, it's not times. Divided.
Divided by 4?
Yeah. So we can do like this, 4 gram over mole. Okay, so gram cancel out. So you have 1 point, I don't know, 6, 7,
1.61.
6 1. Good, thanks. 6 1 mole. Okay, so basically what we did here, we take the molar mass concept of helium, and then we take the value for gram molar mass that we got from periodic table. In case of helium, that is 4. In case of other, we have other value. But because we are dealing with helium, so we take the 4 molar mass, 4 gram per mole. Molar mass means, by definition, gram in per mole, 1 mole, gram per 1 mole. So that 4 gram per mole means, conceptually, 1 mole of helium is equal to 4 gram, or 4 gram of helium is equal to 1 mole. So if 4 gram of helium is equal to 1 mole, now it becomes easy, 6.46 gram of helium to have 1.61 mole. It's just like a relation. So molar mass is important. When you have something in gram, you want to convert into mole concept, then molar mass. All right, next example. Zinc, right? Zinc is a metal. So you see the image. Zinc is a silvery metal that is used in a lot of different ways. One is making brass, that is kind of alloy, steel, mixed with copper and other metal in a specific proportion, and then you get some alloy called brass. And also it is widely used in plating iron to prevent corrosion. Iron is notorious of like corrosion, right? Iron easily corroded in contact with water, atmospheric environment. So if zinc is plated, the iron surface, it prevents corrosion. So zinc is very important. So now you can understand it is used in a lot of different industrial manufacture things. So you need to know, if you work in that kind of situation, you will know that mole convert to gram, gram convert to mole. So how many grams of zinc are in 0.356 mole of zinc? Okay. Now, last helium question was about gram to mole. Now this is mole to gram. We want gram. We have mole. Again, we need to find the molar mass of zinc. But in this case, we will multiply molar mass of zinc equal to 63 something, I believe, right? 63 gram over mole. Okay, so it's the molar. That means again molar mass. That means 1 mole of zinc equal to about 63 gram, or 63 gram is about 1 mole. Depends which way you want. Now we want to go from mole to gram, so we need to multiply with the molar mass. So 0.356 mole times 63 gram over mole. So mole cancel out, you have something in gram. Very easy. Just we have to understand when to multiply and when to divide. When we go from mole to gram, we multiply the molar mass with the mole given. When we want to go grams to mole, we divide by the molar mass to the given gram.
How did we get 63 gram per mole?
It's just I assume that it may be wrong. Have you checked the
Okay.
periodic table?
Okay,
That's
yeah.
right.
I was looking at it and it said 65.39, so I thought
Oh,
maybe I
right,
was.
right. I just, yeah. So write 65. Yeah, approximately. Next question, methane. Methane is one of the principal component of natural gas used for cooking domestic fuel. Methane with the formula CH4, chemical formula CH4 is methane. How many moles of methane are present in 6.07 gram of methane? Again, it is similar to the helium problem. We have gram, we want to go to mole. So that means we need to divide by molar mass. Molar mass of what? Molar mass of CH4. Okay. So molar mass of CH4 is not given in the question. It is needed to find out. So molar mass, we need first molar mass of CH4. So C times 1 plus H times 4. Now it is not a singular element like zinc, helium that we can find from periodic table directly. It is a compound. It is a compound of two different elements, right? More than one element. So compound molar mass you will not find directly from the periodic table. You need to set this calculation first, and then as we learned yesterday, plug in the value from periodic table. That's again still you want to use periodic table, but you need to calculate first. So C value for atomic weight is 12 times 1 plus 1 times 4 equal to 16 gram over mole. Okay, so molar mass of methane we found from calculation 16 gram per mole using periodic table. So now you can write the final math of mole of CH4 equal to 6.07 gram rain divided by 16 gram over mole. The gram cancel out, and using calculator you get some value, maybe some 0.3 something 7 approximately, but use the calculator for accurate answer. Okay, so understand, from gram to mole, you divide it by molar mass. From the other way, mole to gram, you multiply by molar mass with the given amount. Okay, let's do this more. Almost always you need molar mass to solve this kind of problem. Now sometimes you may have the molar mass given in your question already, so you don't need to do that part of work. But if it is not given, you need to calculate based on periodic table. You need to calculate that first, because without having the molar mass, you cannot do this type of mole map conversion related problems. Okay, determine the mass of each of the following. Again, all this problem is related to mole to gram in this way, in this direction. G for gram, mole to gram. Okay, so these are the exercise that's helpful for you to understand this concept. Right, so molar mass, in each case you need molar mass. So molar mass of KOH equal to, so you have, this is a compound, right? So you need to calculate this K plus O plus H. So you need to find that value from periodic table for each KOH and then add them together. And what do you do after that? You got this value gram over mole. Right? You got some value using calculator. And then what you do? You multiply, okay, with the given amount 0.146, 0.0146 mole times the molar mass you just got. Okay, so do that yourself. I'm just giving you the direction. Number B, same way, molar mass of C2H4. Molar mass of C2H6. C2 means 2 carbon. C times 2 plus H times 6. So I know these values, I can find it now. C means 12. 12 times 2 is 24. H means 1. 1 times 6 is 6. So 24 plus 6 equal to 30 gram over mole. Okay? So I just skip one step there, and you will be able to skip steps when you actually do this type of question exercise a lot of time. Okay, so now the rest of the calculation is 10.2 mole times 30 mole over gram. So equal to gram. Oh, what did I do? We're looking for mole to gram. Ah, see, my unit is wrong. It is gram over mole, not mole over gram. Okay, so mole cancel out, and you got 300.6 gram. Okay, same thing, similar way. We need molar mass first. Molar mass of cobalt. What is this name? This is very complex. Actually, it is named a complex in chemistry. CO cobalt, right? We don't need to know the name to find out molar mass. But the name is a little complex. Hexaamino cobalt chloride. 6Cl3. Okay. To find out the molar mass, same way. You write CO plus, because one CO, so CO plus this 6 over NH3, so N times 6 plus H times 6 times 3, 18. H times 18. Okay? Plus Cl times 3. Okay. Is this 6 belongs to NH3 only, not cobalt. Cobalt is just 1 here. We don't write 1. So cobalt plus N times 6 plus H times 18 plus Cl times 13. Now you get the value of cobalt, nitrogen, hydrogen, and chlorine from periodic table. Plug the value in this equation and find using calculator the molar mass. And that molar mass will be similar way gram over mole, right? And then you multiply this amount with that molar mass. That is your answer. You have mole, you want to go to gram, you multiply. Any question? The most important part is to be able to find out molar mass accurately, right? For me. All right, let's do the other way example. Determine the number of moles of each of the following. So here you are given in terms of gram, 5 example exercise for you. So the big picture here is gram to mole. Still molar mass comes here. But in that case, you divide it, you do the division with the given amount, molar mass. So again, first need to find the molar mass. Okay, same way, but on the final steps, you have this amount divided by molar mass. Okay. Clear?
Yes.
Yeah, good. So number C, look at number C. Here you have 23 kilogram. It is not in gram, it is given in kilogram. 23 kilogram of calcium carbonate, so that CaCO3. So what does that mean? That means molar mass you will find in gram per mole. That is the unit. But your given unit is kilogram. So what do? We have to maintain same unit in order to calculate. So you need to convert this into gram first. So we can convert this 23 kilogram, right? 1000 gram per kilogram. We know that 1000 gram is in 1 kilogram. So we need to first convert that 23,000 gram. Need to convert this in gram, and then you have molar mass, and then you can divide it this. Likewise, here you have given number E in milligram. Okay, so milligram is smaller than gram, but we first need to convert this milligram to gram. So I'll leave it for you to solve. Hmm. So, which of the following question represents the least number of molecules? Now it is one step further. So what we have learned. Now what is this? It is, you have given some gram. You need to find mole, and then you can answer number of molecule. Right? Is not that the thought process? So you have gram given. You need to find the mole first, and then you can find out number of molecules, because we have another important relation. We know 1 mole equal to 6.022 10 to the power 23 molecule. So this is our great Avogadro relation. So when we find the number of mole, it is easier to find the number of molecules. If number of moles is very less, molecule number will be very less. If number of mole is very high, greatest, then number of molecule will be greatest. Anyone have any question with this relation? Or do you really understand? If not, I can explain more, because as I said always, to solve a problem, you need to understand the problem. The thought process need to be accurate. So this is the question asking 5 of them, which of the following, comparison, which of the following represents the least number of molecules? And you are given gram amount of some 5 chemicals in here, right? And the good thing is that each of the question have their respective molar mass given. When you say gram over mole, there is a molar mass. So you don't need to actually find molar mass. So think like this is a great help. You don't need to find it. So you can quickly answer, compare all of them. So what we have to do first, because molar mass already given. So to find out mole, you need to what? You need to just divided them with that molar mass value. So these are all molar mass. Okay. So easily you can find out, right? Number of moles. So the final answer will be least moles is least molecule. So you will find the mole value from each of these, and then you need to see which one is the least in number value. Then that is the least number of molecules, because 1 mole equal to this Avogadro 6.022 number, right? That's the relation. So least number of mole means least number of molecules. Anyone have any question with that, or everyone is good, or any type of question you can ask? Maybe you need more explanation. Basically, we are trying to have learn the mole related exercise in different way. Okay, because you have to do in different context, you have to use them and find the calculation. But these are all mathematical concepts, but I am trying to dissect step by step process. Any question you can ask. I'm not writing the whole solution here. My job is to just show you to the path, the way you have to do. But it is you need to do this exercise to understand this concept. Okay, so we'll take 3 minutes break and I would allow you to think about this. All right, we are back. Anyone have any question? Okay. Okay, so more question. Copper is commonly used to fabricate electrical wire. How many copper atoms are in 5 gram of copper wire? So again, it is given in gram. We need to find in mole, and then from mole we need to find number of atoms using Avogadro number. So what is the molar mass? We need molar mass. Molar mass of copper. Cu is for copper. Molar mass of copper. I believe it is about, I don't know, I don't remember. Anyone help me with that? So gram over mole. Okay. 63.54 gram per mole. So what we do now, we need to find the number of mole of copper atom. Okay. So 5 gram, right? 5 gram divided by 63.54 gram over mole. Gram cancel out. So need to use calculator. So we got 0.079. Okay, so mole. But we need to convert again mole to number of atoms. So multiply with Avogadro number 6.022 10 to the power 23 per mole. Okay. Atom per mole. Don't have much. Atom per mole. Mole cancel out, and then you have something 6 times 6.022 equal to 0.47 times 10 to the power 23. A lot. Okay. 0.47, or you can just, if you want to be very accurate, then write 4.7 times 10 to the power 22. Our body synthesizes protein from amino acid. Okay, this is just describing a physiological process in our body. where you get protein. It is coming from amino acid continuously. One of this amino acid is glycine. Okay, we have more than one amino acid. Actually, we have 20 amino acid in our body naturally functioning. And one of them are glycine with the formula C2H5O2N. As I said, human body is a giant chemical factory. So this is one of them. C2H5O2N. How many moles of glycine molecules are contained in 28.35 gram of glycine? Okay. So just a lot of description, mostly about what is glycine or not. But the question is very simple. It is asking you how many mole of glycine molecules are in this gram. Okay, so basically you are going from grams to mole. Okay, so you're going to gram to mole. That means again you need to find molar mass of this C2H5O2, using the periodic table the way we learned. You find the molar mass and then use that molar mass to find the mole. So you have given 28.35 gram and you need to divide it by that molar mass to find the mole. So we have done that a lot. I will leave it for you. Okay. We are doing a lot of exercise because we need to really understand. This is very important, not just for this chapter. The chapters followed, next few chapters also use this concept. Mole concept is everywhere in chemistry. Molar mass, moles, Avogadro number, grams to moles, moles to grams, grams to number of molecules, grams to number of atoms. These are very, very important. Okay, next question. Vitamin C is a covalent compound, okay? It's a covalent compound between non-metal, as you see. All are non-metal, carbon, hydrogen, oxygen. So you can say it's a covalent compound. It's a not ionic compound. Vitamin C is a covalent compound with that molecular formula C6H8O6. The recommended daily dietary allowance of vitamin C for children aged 4 to 8 years is 1.42 times 10 inverse 4 mole. What is the mass of this allowance in grams? Okay, so it's like a doctor writing the dose, daily dose for the children, but doctor normally don't write in terms of mole, right? Which they write in terms of grams. But it's okay, we can convert moles to grams. So basically it is mole to gram. Again, we need to find, using this formula, we need to find molar mass first. And in that case, we will multiply the molar mass value with this given mole value to find the gram. Okay, simple. Next question. 55 kilogram women has 7.5 10 inverse 3 mole of hemoglobin. Hemoglobin is a protein. Every human has this protein, hemoglobin, in blood. That's why it is red. Now let's say a woman of this 55 kilogram has this 7.5 10 inverse 3 mole of hemoglobin in their body, in their blood. Okay, how many hemoglobin molecule is this? What is this quantity in grams? So two part of this question. First, the quantity in grams and how many molecules. So what is the thought process? We don't need to find molar mass anymore because it is already provided. And see the molar mass, 64,456 gram over mole. So in 1 mole of hemoglobin, it contains 64,456 grams. It's a huge, bigger molecule. As I said, molecule can be giant, like protein. Hemoglobin is a protein, and it has thousands of atoms involved. So that's why the molar mass is very, very big. And you don't need to find that out, that very big. That would be, um, if you were to calculate, that would be nightmare, right? A lot of time. But it is given to you, so we just need to use that. What we do first? We can first find out the gram. So this second part, we can first find out. This molar mass times this mole. You get the quantity in grams. Right? Okay. Any question? No question? Everyone silent. Okay. I hope you are listening. So that's how you got that. How many hemoglobin molecules? So now the other part of the question. How many hemoglobins molecule is this? So you can directly find that by using Avogadro number 6.022 10 to the power 23 times 7.5 10 inverse 3. Okay, Avogadro number times given mole is equal to number of molecules. So this is your second part. Okay. And you see the 55 kilogram value, the weight of the women is not relevant here. Okay, it's just like confusing, tricky situation. We don't use that value 55 in our calculation. All we need is just the mole, molar mass, and Avogadro number. Any question? Okay. We have one more big question left. And this is very important. So you see the picture of urea? It's a granular white color things. Anyone know the use of urea? Okay, so I will post the homework today after this chapter. So urea is a urea used as a fertilizer, animal feed, and other type of manufacturing process as a polymer raw material. So urea has this formula. Urea formula is NH2 CO. Okay, this is the urea formula. So what is the question? What is the problem? How many hydrogen atoms are present in urea of 25.6 gram? Okay, it's a very simple question. You have 25, let's say this is your 25.6 gram urea in this picture. Okay, you want to know how many hydrogen atoms are in it. So to find that, we need molar mass of urea, and it is already given to you. 60.06 gram per mole. Okay. So how many hydrogen atoms are present? How to find that? What is our thought process would be? Right? So we need to find gram to mole urea grams to mole urea, right? We need to convert that. This is our thought process. How? Using the molar mass. And then mole urea to mole of hydrogen atom. Mole of hydrogen atoms to number of hydrogen atom using Avogadro number. So it's a multi-step conversion process. Okay, it's a, even though it seems a small little problem, but it's not. It's a multi-step problem. So let
And
me
for this
ask you a
one,
question.
we're not using, it's just hydrogen. Out of all those atoms, we're just focused on
Yeah,
hydrogen.
yeah, yeah. Just we are looking on hydrogen, just hydrogen. But if you understand this just hydrogen part, you can use that same procedure for other atom like carbon, oxygen, and nitrogen. So we are just using hydrogen as an example here. So let me ask you a very simple question that we learned before previously. How many mole of hydrogen, how many mole of hydrogen in 1 mole of urea?
Well, I guess I, I would think it's 4.
Yes, it is 4.
Okay.
Yeah, you're thinking right. So if I say how many atom of hydrogen in 1 mole of, sorry, how many atom of hydrogen in 1 molecule of urea? Right? So how many hydrogen atom are in 1 molecule of urea? It's just like very simple question. Okay, so anyone? We have learned that before. No one? We need to understand the concept better.
Yeah, I'm just not understanding, I guess, this problem.
No, forget the problem. My question is how many
Would it be
hydrogen atoms are in 1 molecule of urea? This is my question.
4?
Yes, so that was my questions. 4. So when I ask how many mole of hydrogen per mole of urea, the answer is 4. Same way when I ask how many hydrogen atoms are in one molecule. Sorry, one molecule. That is also 4. Okay.
Okay.
Any question why? You can ask why. I have explanation, but if you don't ask, I will assume that you understand. So molecule and mole are not same, but why the answer is same?
Because the mass is 1 of 1 hydrogen.
Yeah, it's like proportion, right? So when I say one molecule urea, that means NH2CO have 4 hydrogen atoms, right? Because H times H2 times 2 times 2, 4. When I say 1 mole of the same NH2 H2 to CO2 CO, I am writing the same amount of atoms, right? Because when I say 1 mole, I am saying 6.022 10 to the power 23 molecule. I'm saying this use number. Instead of this use number, I'm saying 1 mole. Avogadro. This much molecules of this urea, right? So this molecules of urea will be 4 times 6.02 hydrogen. Does this make sense? So if I say 1 mole of urea, it will be 4 mole of hydrogen. If I say 1 molecule of urea, then it will be 4 hydrogen atoms. Okay. So the strategy, because it's a little large problem, but very important, I have given the explanation. We are asked to solve atoms of hydrogen in 25.6 gram of urea. We cannot convert directly from grams of urea to number of atoms of hydrogen. So how should molar mass and Avogadro's number be used in this calculation? How many moles of hydrogen are in 1 mole of urea? So these are our thought process. To calculate number of hydrogen atoms, we first must convert grams of urea to moles of urea using the molar mass of urea. This part we already learned, right? The molecular formula of urea shows there are 4 moles of hydrogen atoms in 1 mole of urea molecule. So the mole ratio is 4:1. Okay, 4:1. Finally, knowing the number of moles of hydrogen atoms, we can calculate the number of hydrogen atoms using Avogadro's number. We need two conversion factors, molar mass and Avogadro number. So this is your solution. So this is your thought process: grams of urea to moles of urea, and you see here is molar mass. Moles of urea to moles of hydrogen. Here is your proportion 4:1. Moles of hydrogen to atoms of hydrogen. Here is your Avogadro number. That Avogadro number. Here is your ratio. Here is your molar mass. Now, this is a multi-step conversion calculation. You can do this one step, or you can do it in multi-step separately, doesn't matter. Okay. So what is given? 25.6 gram of urea, and then molar mass of urea 60.06 gram. So this problem is actually using unit one-dimensional analysis that we learned before. One-dimensional analysis, the use of it is help you to calculate multi-step process in a single step. That's the use of it. But you can obviously not follow one-dimensional analysis, but can show individual step-by-step process if you want. Okay, so molar mass 60 gram of urea, 1 mole of urea. 1 mole of urea means 4 mole of hydrogen. These are the conversion factor relation. 1 mole of hydrogen means this Avogadro number of hydrogen atoms. Now finally you can cancel out this. This is your answer. Okay. So I know it is still complex for you, but you need to really spend some time on this problem. You spend some time on this problem and you will understand. And what is a good strategy of studying? Self-study, right? I always be curious, right? Try to challenge yourself in a different way. So once you understand this problem, then the next step I would do, that's strategy. I would be curious. I would try to follow the same problem, but for different atoms. Okay. For example, once I understood that, I would challenge myself. Instead of hydrogen, now I would try to find how many oxygen. Okay, using just the same value, same thing, just to change the different oxygen instead of hydrogen. So if you do that, how you'll solve this? Okay, need to think about. Maybe next step would be, instead of oxygen, I would try to find for nitrogen. I would try to find then carbon atom. Okay, but once you understand this for hydrogen, just one type of atom, then only you can tweak a little bit, change different things. Okay. So for oxygen, here is the place. I'm just giving you the clue. If you are curious for oxygen to solve it, here is the place you will change the value only, and everything remains same. Here is the place. You will need to write, instead of 4, you need to write 1 mole. 1 mole instead of hydrogen, 1 mole oxygen per 1 mole of urea, because this formula. And then you need to write here oxygen as well. So only the value is changed for oxygen in this part of the calculation, nothing else. Understand? The ratio of oxygen atoms to urea. Now let's say you want to find that for carbon. Okay, so only this value will change, but you see carbon and oxygen are same. Carbon is also 1 mole, so the value does not change, just oxygen becomes O becomes C because 1 mole of carbon in 1 mole of nitrogen, everything remains same. If you want to find it for nitrogen, then what? Here you will be writing 2 mole of N. Okay, okay, so this is the way I would learn this type of problem, right? So I can just solve and teach shows only few of the exercise, but if you have if you need more exercise, if you get more curious, you challenge yourself. Just change the value of question given in my lecture slide. Like change the question value. You can even change this amount to instead of 25, you can change into 78 gram. Okay, change the value and then solve that. Challenge yourself. Try to make a different problem and then solve it. That way you will learn better. Okay, so that is the end of this class today. Watch the record and so basically we covered this, and this. We did not cover this too. So basically, we finished this chapter and we have